Hello everyone, welcome to this video. Let's continue with our study of properties of cosets. So here is the question that is whether left coset is equal to right coset for a given subgroup in a group G. So this property tells us the answer to this question. Here it suggests that the left coset AH is equal to right coset HA. This is not true in general, but this is true whenever we have H is equal to AHA inverse. And conversely, if we have the left coset is equal to right coset, then this thing would be there, and if H is equal to AHA inverse is there, then we have both of them as equal to each other. So basically here also you can see that the equality of the left and right cosets here which contain A, this leads towards the equality of two subgroups within the group G, because you know H is given to be a subgroup to you and AHA inverse is also given to be a subgroup. So you see how in proofs we can use this property as shifting the equality of cosets to shifting the equality of two subgroups of G. Okay, moving forward towards its proof, we first of all suppose that AH is equal to HA, the left coset is equal to right coset. We need to firstly prove that H is equal to AHA inverse. So you see the proof is if and only if case. So let's consider AH is equal to HA. Now this thing would be there if and only if we have AH is equal to A inverse, right? What we have done, we have post multiplied on both sides by A inverse. So we have AHA inverse is equal to HAA inverse. Now on this thing we can apply the associative property so that it becomes AA inverse, and this AA inverse becomes E, and you know E is present in H because H is a subgroup of G. So therefore HE would be equal to H, correct? So that means from here we can clearly see that this HA inverse is equal to H if and only if, right, we have the left coset is equal to the right coset, and this proves the result in both the ways, correct? Okay, moving forward to our next question. The next question here is, are all cosets of the subgroup H in G, they are subgroups of G? Is it true, right, that all cosets of H in G are the subgroups of G? So the answer is no, they are not. So is there any condition or restriction over to it such that it becomes the subgroup? So there is a restriction or condition. So what is that? This is given by our ninth property. So it tells us that if AH, which is a coset, you know, the left coset, this would be a subgroup of G, right, whenever, if and only if this element A belongs to H, right? And so you see this is a beautiful property here. Why? Because in this case the property suggests that H is the only coset of H that is a subgroup of G. Why? Because you know if A belongs to H, this is the property that we have already studied. So in that case AH is nothing but equal to H, right? This is the result. So using this thing here, AH is what? It is H only, and you know H is the subgroup of G. So H is the only coset which is a subgroup of G, and no other coset is a subgroup of G. So this is the ninth property here, correct? So moving on to its proof, let us first consider that this AH is the subgroup of G, and we would like to prove that A belongs to H. Now because this AH is a subgroup of G, so it would definitely contain the element identity within it, and moreover this identity is also present in EH, right? This coset EH, which EH basically is H only, and H being the subgroup would contain this identity obviously, right? This is given to you in the question that H is a subgroup. Okay, AH is a subgroup, it contains E, moreover H contains E, so EH would also contain E, so their intersection would contain one element which is E, the identity element, so therefore its intersection is non-empty. Now according to the fifth property that we have studied, that the two different cosets, either they are identical to each other or they are disjoint to each other. So in this case we are saying, because there is one element present here, this intersection is non-empty, so that means this has to be equal to each other. Why? Because we can have either of these two cases and no other case, therefore. So if you have one element, so that means all other elements would also be the same within these different cosets. So that means this AH would be equal to EH, and what is EH? That is H, right? So from here you obtain AH is equal to H. So by the property 2, if you have AH is equal to H, that means H absorbs some element, that element would be present in that subgroup only. So this A would be present in H, and this is what we wanted to prove here in this part. For the next part, what we do, we assume that A is present in H, and we will prove that AH is a subgroup. Correct? This is what we wanted to prove. Now according to second property, if A belongs to H, then AH would be equal to H, right? If AH is equal to H, and it is also known to you that H is a subgroup of the given group G, so therefore AH is also a subgroup of the given group G, and this is what we wanted to prove here in this part. So I hope you understood these two properties of cosets. Well, that is it for this video. Thank you for watching.